So let's introduce myself. I'm Timothée Raulin. I started in the industry quite long ago, in 1999. So I start with in agent system, and I mainly did made real-time strategy game with a lot of military stuff. And particularly, I made rules, and it was the first time we made large-scale terrain. You can be at the ground level, just beside a tank, and then in one mouse wheel, and you are just in the satellite view, and you can embrace the whole battleground. At that time, it was full C++, and everything was baked, cooked. Then I made 2 opus of Wargame, which is similar technology, and then I switched to a new company, Amplitude, and I made Endless Legion. It was my first contact with Unity, and I learned how the C# is slow. And so I start to make more stuff on the GPU. Even in DirectX 9, I made some kind of instancing. And then we made Endless Space 2. It was the first they asked me to make battles with tens or 20,000 of laser in the air. So it was my first GPU FX system because we cannot use the Unity one, which was very too slow. And then Humankind, that was released in 2021, and what we will talk about. So, our methodology. After watching all the very cool presentation, I felt a bit an imposter because everything I will talk about is very, very simple and basic. It's simple, but it was enough to ship the game, so it's battle tested. So I will talk about the general constraint of the game, which leads to all of our decision, and the concept, only the concept, and some sample of how the general concept works to produce what we need. And I won't talk about the specific GPU technique, but you have to know that everything runs on the GPU. Everything, the FX, what you see on the screen. I won't talk naturally about implementation detail, and I won't talk also about the terrain that is underlying the object, which could be interesting, but it's not that to speak. So what is Humankind? So Humankind is a 4X. 4X come from explore, expand, exploit, and exterminate. So the genre starts in 1991, I believe, or maybe before, yes, and with civilization. So it's a 30-year genre. We try to enter in the big contest with civilization. This time they won, but we're ready for the next time. So what is in the 4X, very important thing is the map is procedural. I won't speak about the way the map is it's produced, but it's different in each game. So we cannot cook everything. We have to adapt to the new map generated. We choose to use hexagons to describe our worlds. You can choose square, and there is also 4X that try to just not use hexagon or tiles at all. And very important, you start in the Neolithic, so with the Eden Garden, with everything natural, only animals. And you finish with a walled city, a city that spread on the whole world. So it's very, very dynamic. You also have a large zoom, So you can be very high and see most of the world, in fact, and the planets, and you can move very fast because you have to switch between city, army, and so. So the camera is very fast. It's very important. There is a lot of content in the game because we start in the Neolithic and we have 6 eras, and in each era there is 10 factions. So if it's made 60 factions, so it's made a lot of content. And the dynamic. So there is a map editor, so you can draw your own map. So everything should be dynamic, interactively. So it's that you can, and there is also terraforming that while the game is running, the map change. So the most obvious thing is you put districts or city part on it, and it changes the underlying ground. We can cut forest and etc. And we use Unity. So in C#, and we could use C++, but I'm not a C++ guy. I'm no more a C++ guy. I'm more a GPU guy now. And so we decide to use compute shader. So our target is shader-capable, compute shader-capable GPU. So DirectX 11, Vulkan, PS4, Xbox, and not Metal, because it just doesn't work. It works on some machine, but on some hardware, but not all. So I call the speak from L system to Humankind because I will compare our method with the general terms used in L system. I think everyone should know what is a L system, and if you are here, but for the sake of the speak, I will explain it. So an L system is 3 parts. So first is a collection, an alphabet of terminals and variables. Terminals are just, at the beginning there was just literally an alphabet, so it's with letters and values. And there is also, but we will expand it. It won't stay letters. And there is variables, it's letters that could be changed by rules. So projection tools. So projection tools are rules that change variables or terminals into new variables and new terminals. And by using the projection rules multiple times, you can produce very complex stuff. And also there is an initiator, so it's the first element you put in the system. So L system is very interesting to produce grass-like things. So the simplest example is there is a stick with a bird on it on the top, and the bird split itself in two sticks with a smaller bird on the top of it. And if you repeat it many times, you can produce things that look like grass. So I have a more example from the L system Wikipedia article. So it works well for grass-like. If you could try to make trees with that, but it's not enough. It's not enough. It's not sufficient to produce a real content. I have a personal experience with L system because my father, in the early 90s, wrote a small program, and I had the chance to play with it, and it was a blast, and it was my first step in the procedural world, and I think it had a role in my current career. No, I choose this way, apart because of this experience. So in our game, there are not many terminals. Okay, I should check the hours. So First, there's visible object. So basically, 3D objects, classical geometry with texture on it. There's plants. Plants are not rendered the same way that 3D object because of their very high frequency issue with when you try to draw plants. So it's an imposter system. There are also decals on the left side. It's just object backed on the, not backed, sticked on the ground, and also VFX generator. In fact, everything is VFX in our system. So VFX is just a specific part of our system, but everything is VFX in fact. So there are also world-light spawner. So it's invisible things that spawn small animals on small car, and so which make the world so living. And also SFX and audio generator. So basically, it's just points with attributes. In this attribute, there's position, rotation scale, and other parameters. And there is a lot of them. So if you, a small, a kind of large map, which will contain 200 multiplied by 80 hexagon, and if you put 10 to 200 objects on it, it's up to 3 million objects. And our system has to be able to handle 3 million of objects. So it has to be fast. So we use only a few concepts to produce all of content. The first one is the easiest one, is the multiplier. So it takes a variable and it produces a new collection of variable of points. It takes points and you produce a new collection of new points. Now, obviously, it takes into account the scale, the rotation, the position. So, and all of these objects are manually set. So it's not the generative. It's just an artist will explicitly set the different position of the sub-object and set all the attributes. And also there is a variance, some variance. So first you can add probability per object. It's very simple. Don't forget that everything runs on the GPU. So you cannot afford to have very complex rules. Everything should be very basic. So you can add probability for each generated point. There is a chance that the object doesn't appear, doesn't be produced. And you can also choose not to produce all the points, but just pick one element in the collection, or 0 if the sum of probability are below 0. It means that maybe you just want to produce or not an object. So with only this, you can produce or temperate forest. So each tile contains gameplay information. There is a biome, there is a terrain type, there is elevation, and lots of other data. And our goal is just to make a feedback of that for the user. So we need to represent temperate forest, for example. So in our case, there is an initiator that is spawned by another system in each tile of temperate forest. And first, we use the multiplier. We produce a multiplier that have 6 different, it produces exactly the same object but with 6 different directions, and we choose one. And the chosen element will then produce 3 different parts. So imagine that I only choose one rotation, okay? And 3 different parts. And then if you take this one, we build 3 different layouts of other sub-elements with different layouts, and which pick one. And then, finally, the random tree that is produced, we have different variant of object or collection of object of different trees, different kind of trees, and we choose one. And with that, we have we can produce a lot of temperate forest, everyone, and there is no repetition. It's not so easy to manually make the layout. You have to be very careful on the side, for example. But it's possible. And it's fully artistic driven. There is no random, except when you choose. The only random is to choose, is not to place object. So to define that, we only need the initiator, random, 3 parts. So each time it's a file, it's an asset. And then 3 multiplied by 3 line objects to define the different layouts, 1 selector, 1 randomizer, and then the different kind of tree. It's only 20 assets. So it's manageable. I repeat, we have a lot of content, so we have to keep everything as simple as possible. But it's okay, but if we only use this kind of only multipliers, we have to do a lot of different variants. For example, for the different forests, for different biome, for different. And so it's a bit difficult to manage all the complexity. So we use the third ground rules. It's a selector. So a selector just pick one item in the list depending on an integer value. So it's a criteria. We call it a criteria. So criteria can be whatever you want. In our example, it could be the biome. So temperate, Arctic, or so the terrain type, but it could be also gameplay information like faction, damage level, or whatever you want. The only thing that is needed is it to be an integer. It cannot be floating values. So for example, if we change, if we want to make every biome's forest, we could just repeat the same sequence as we did for the last forest, but instead we just change the way we produce the forest. So it is the same first step, and there, I click it too much. At the end, instead of randomize the tree, we insert a new element, a selector, that will select the random tree based on the biome. So I don't only draw 2, and with that, you have all the forest, and you only add 1 intermediate object. So when you count how many object you need for 8 biome, it is there, doesn't change until here. And then obviously there is more data because we need to make all the 8 different random tree and the additional selector. So it only 63 assets. So we save more than half of the objects needed. And also, the first part is kind of abstract for artists, so you save it for them. You hide it. They just have to care about, okay, make 1 random forest, 1 random trees. So it's easier for them. And then not the final, the filter. So based on condition, you can kill object. So if a tree is spawned on a river, obviously you have to disappear. If it's on a mountain or things like that. And also from roads. So I make a draw. So before spawning the random trees, we just remove some generated point. So if it's on the mountain, remove it. If it's on the river, remove it. And if it's on the road, you can also remove it. But the roads are themselves on the GPU. So the objects have to figure out if they are on the road or not. So we introduce a new invisible terminal. So you cannot see it, but there is debug. And their role is to tell the other environment, here, there is a road. So if you are spawned here and you don't want to live on the road, you kill itself. You kill yourself. And that's all. And yes, the select from the biome there. So I made a small video. And is it play? No, it's not play. Okay. Yes, so I brush forest everywhere. And then I brush water, and you see on the beach, there is no trees. So, because trees know that if they are spawned here, they want to die. It's actually the same for some trees. And look at, some trees are still living on the forest, because we say that. And then we change the biome, and trees change. And they also adapt when the beach change or the cliffs change. Okay. It's a bit too simple because we have other cases. And for example, the waves. So depending on the coastline, we need to produce different waves. So if there is only one side, it's a simple wave. If there is two sides, it's a different wave with the correct orientation. So how do we handle that? You can introduce special case for this kind of case. You also have fortification, so a city. In Humankind, fortification is a status of the hexagon. So the district is fortified. It's not specific age that has a fortification. So obviously we cannot make fortification inside the city. It would not make sense. So we have to know, the system have to know if they need to produce a fortification or not based on the environment. What is that? I don't know. Yes, it's a specific case where in the specific object on an hexagon, you may change the way the hexagon should be rendered. So, as I said before, we are on the GPU, and if you know how works the architecture of the GPU, it's a SIMD, so a single instruction, multiple data. So we have to keep the computation the same for all objects. It has to use different data, but the same computation, and the same for all the threads that are running together. So we have to, we can't use traditional C++ or CPU way of doing stuff. We have to have a more simple system and more parallel. Okay, so we add a new rules. A new production rules based on, we say, matching. So it's basically what matching is a set of conditions that containing containing a zone on its neighbors. Oh, it's barely readable. Yes. Okay. So each condition is easy to compute and contain only data from the hexagon. So I put some there. Is there a battlement or not? Is there a sea? What is the level? What is the different level between the center of the hexagon and the other hexagon? A lot of stuff. And it's easy to compute because it's only true or false for the hexagon, and the data are already there. And you just have, if all the conditions on one matching rule are met, you produce the content. If not, you just pass and go to the next condition rule. So a rule is just a set of conditions. Let's see, we can use more, yes, you can use more than one matching. Only the first that succeed produce its content. So for the fortification, let's start with the same description. You have an initiator, and then you produced 6 times. It's not the random. This time it's 6 times you produced for all the direction, for all the districts. And the role is, if the center hexagon is fortified and the other hexagon is not fortified or is not a city at all, produce a fortification. But if the neighborhood district is also fortified, don't produce it. And there is more complex rules, like if it's not the same empire, it's not the same city, you should produce an hexagon. That's why there is specific rules in the top corner, same empire. So the rules just look like stuff like that. Is there a battlement or not? Here, you should not have a battlement, and inside should have a battlement. So the small cryptic letters are just described in short the conditions. And it's a waste of computation a lot, because each district in each city will produce 6 maybe fortification, and most of them will just be wiped out and won't produce anything. So for the fortification, so we decide to produce a fortification, then we use a selector, depending on the faction, to have the different style, the different way of representing a fortification. Then, depending on the level, is there a level 1 fortification, 2, 3? It's another selector, and etc., etc. There is a damage level, etc. So this sample is quite simple. And then there is more complicated stuff, like for the wave, where there is a lot of condition. First, you have to, if you have 6, if you are a single tile with 6 coastline, you make the wave like that. If you have only 5, only 4, etc., etc. But it's manageable. The complexity is manageable. Yes, and also, I didn't speak about that, but the system is able to turn its rules. So if I produce an object like that, it will use the classic rules, but if it's spawned like this, it will rotate all its rules. So a small tool, so I choose the Netherlands for that. And as you see, there is some example. For example, we don't produce fortification if there is a mountain, because not needed here. It's in the rule. You have to be non-fortified and not a mountain. And here we know that it's now this exit of the city, and there is a road. So here, exactly, there is a spawner of the small travelers. So they spawn here, and then they follow the road. And you can express it with, so I can say, I should have shown a road in the forest. Okay, I didn't do it. Yes, that's all. I have to, hurry. Okay, then next, the bad stuff. How to refresh. So we choose to be deterministic. So I can refresh when I want, and it will produce the same content, except if something has to change. So if I time correctly object data that will disappear from the previous iteration of the tile, and I time it correctly, the new object will replace it the old one exactly at the same frame, so you won't notice anything. But you cannot animate, because basically I can't know in advance if an object will disappear or not. Also, how to cull. So it's not easy to cull things because of the warm-up time. So if an object has almost no state, it's easy to cull, but if there are an object with state, it's not easy. For example, we have weather, which slow clouds that appear and then make the life, and we can't cull it. It's not possible. So we choose to keep them. And because we are able to manage millions of objects, it's possible. So the system is simple, but it's fast, very fast. So it runs on the PS4. And it can handle, even on the PS4, it can handle less than 1 million, but nearly 1 million of objects. It's battle tested. We managed to release the game, and it works well. And we have millions of objects. And it's okay because the view is not so close. It works in all particular case because the camera is not so close. You cannot see the small glitches that are everywhere. If you pay attention, you will see there is everywhere there's some stuff that's not correct. Object on the road and stuff. But it's okay because we need to be very, very fast. So there's still open question in the system. There's how to handle reflection animation. I have no answer for the moment. It's manually, we say, okay, I know that the disk changed, so I will produce a refresh animation, but it's not. It's not easy. There are many technical issues. It's not easy to put. Yes, and that's all. Thank you.